All right, factoring review 2j. Now this is the first expression that we've run into that has looked like this. Okay. Notice, first of all, you got to look for common factors. Okay, and I see a bunch of x's here, but I don't see an x in that last term, which means x is not common, and as such, there's nothing common to these four terms here. So now I see four terms. Now at this level right here, the way we want you to approach this is we want you to approach this by grouping. Okay? So what we're going to do is we're going to group together the first two terms. We're going to put a plus sign in between, and then we're going to group together the last two terms. Okay? Now, regardless of what sign is in front of this third term here, I'm going to push that over here, and I will put a plus sign in between. It's important that you catch that because it's going to be tempting, quite honestly, to put the wrong sign in there if you're not careful. But once I've grouped together the first two terms and grouped together the last two terms, I take each one of these binomials and I start looking for something that's common between the two terms here. Now, here, I think it's pretty clear. It's got to be x. Then I compare the exponents, a cube and a square. Well, like I've done a bunch of times before, it's the smaller exponent that I'm going to take out. And so that leaves me, that first term here is x. And then remember, this x squared is being distributed to two terms here to get those two. So it's x squared times x, and then plus, well, that's got to be a 1. So it becomes x cubed plus x squared when I multiply that out here. This factor over here, x plus 1, there is nothing in common between those two. It really is just x plus 1. That's the best I can do. But now look at this. There is... And this might be hard to see. I know some people do this, as soon as you start throwing in the variables here, it becomes unclear here. But look at this. There's only two terms here. I've gone from 4 terms to 2 terms. Now, some people might say, yeah, but there's a plus sign in here. Isn't that more than that? But no, as soon as you do this multiplication, that becomes 1 term, and here's another term. Those brackets there group that together. It's just 2 terms. There is something common to both of those. There is an x plus 1 common to both of those. If you have a hard time kind of seeing that, then what I want you to do is think of it like this. You don't know what x is. You have no idea. It's a variable. It could be anything. But if you don't know what x is, then you don't know what x plus 1 is. Let's just call it a. Okay? Just for convenience sake, call it a. And that means that this is x squared times a plus a. Okay, so I'm just going to rename that little expression, that binomial. Now, it's a lot clearer that, oh, between those two terms, there is a common factor of a. So I'll write that out front. And if I distribute the a to the two terms, then what must have been there was x squared in that first term. And then a times what gets you a? Now, a lot of times when people take an a out of an a, when that second term, they just leave that blank. They just drop it. But there has to be a 1 there, so that when I multiply that back through, the a has something to multiply into. Now, I can't leave it like this, even though that is factored. I can't leave it like this because a was not part of the original expression of the question. So I have to go back and say, okay, I said that a was x plus 1, so this is x plus 1 times x squared plus 1. And that is the final expression factored. I'd look at this one to see if I could factor it any further, but that is the sum of two squares, not the difference, and I can't do anything with the sum of two squares.